We're going to take a look at the standard normal distribution, but this time instead of calculating the area, we're going to calculate a value corresponding to an area. So let's say, for example, we want to look at the top 15%. That would be a right tail area of 0.15. And so we're just changing this operation. This is called the inverse operation. And we're plugging in an area, and it's going to shade that area. You can see that there. And tell us what it shades to. So imagine it shading from the right and saying, okay, we're landing at 1.036 or about 1.04. In the notation, you might see that a couple different ways. It's going to be the top 15%. So we're saying that the probability that z is to the right of some number that we don't know is 0.15. And we want to know what that is. Sometimes we'll put a c there or a different variable. I usually just write it this way, 1.04. That was approximately. You could rewrite this now. Probability of being to the right of 1.04 is 0.15. You could also have the bottom percentage. Let's say we look at the bottom 48%. Now that's actually, there's a notation for that, and that is P48, or the 48th percentile. And so we could just write down this notation, but the other way to write it is z is to the left of some number we don't know, and that's outputting a 0.48. So we're still on this reverse operation, calculate a value corresponding to an area, 0 and 1, with a left tail. This time it was 48%, 0.48. So we see that z is negative 0.05 for the answer to that. Okay, so some of these might be very small. Some of these z's could be even past 3 or 4 if the probability is small enough.